continuing where we left off, where does radiation originate? As I said, it originates in the atom, and you need to protect, otherwise it will lead to tissue damage and, in extreme cases, death. So, what's the aim of this experiment? To detect the background radiation for the first part using the Geiger counter, and after that using that Geiger counter to detect radiation from the standard alpha, beta, gamma sources, as well as some everyday objects like glow lights, smoke detectors, Fiesta-Ware, lantern, mantle, salt substitute, and the americium 241. So, what's the hypothesis? Part 1, I'm predicting that the background is going to be pretty low because it's a controlled lab environment. Part 2, I'm guessing that the alpha is going to be low because of the fact that it doesn't travel very far. And then probably the gamma is going to be high because it travels the farthest. And then looking at all the everyday objects, maybe the colored Fiesta-Ware has some kind of paints that might emit high radiation. Again, as I said, hypothesis, there's no right or wrong answer. You're simply making a prediction based on what you think you know from your previous knowledge. All right, and then of course the smoke detector, which is intact, will have lower radiation compared to the exposed americium 241, which is the actual source inside the detector. The salt substitute, because it's something that's going to be used, a food, and therefore the FDA is not going to allow any kind of substance which is potentially harmful to be used as part of our regular food consumption products. So, materials and equipment, make sure you provide a detailed list of everything, and then describe what you did in your procedure. And then the observations, the data was, the background was about 40 CPM, and then we talked about this in the previous video. As you can see, the intact smoke detector is 0, but without the plastic it's pretty high. And then the lantern mantle also has a high radiation, as do the beta particles. So my prediction was that the gamma would be high, but actually the beta has a very high radiation. So my results, background was low as expected, but the beta standard having such a high radiation, it wasn't as expected. I was expecting the gamma to be higher. Also the lantern mantle, since I didn't know much about it before I did this write-up, I didn't anticipate it to have a high radiation. The Fiesta-Ware is low, and that's good because that is going to be used again as utensils to be eaten off of. So of course it has to have a low radiation. The smoke detector, that with the cover it has 0 radiation, is good to know because that shows you the importance of having that plastic cover. All right, americium 241, when exposed, has a 10,000 CPM, pretty high radiation. So background radiation was low, so that supported my initial part 1 hypothesis. Part 2, of course, was slightly different than what I was anticipating. So what did I learn from this? The importance of checking background radiation in any environment where I'm going to spend long periods of time, whether it's my home or my office. It's not expensive to obtain one of those small Geiger counters and run background tests myself. So some real world examples of knowing of needing to know what the background radiation, especially to have the basement area tested frequently. All right. And then especially if you're living in an old house, to make those frequent tests for background radiation in the basement, because prolonged exposure can be very harmful. Okay. So again, part 2, I was surprised that beta standard had such a high radiation as opposed to the gamma standard. Okay. The lantern mantle, again, I didn't know why it had such a high radiation until I looked into it further. And the reason for it is it's emitting both alpha and gamma rays, all right, because it's made up of thorium, and therefore thorium is both an alpha and a gamma ray emitter, which explains why it is emitting such high radiation. The glow light is next, but it's not as powerful as that lantern mantle, right? So it's got a much lower level of radiation. The Fiesta Wear was low, and that's within the permissible FDA limits of radiation emission allowed for footwear items. And then so instead of using lantern, just use flashlights to minimize radiation exposure. Make sure that you have a good plastic cover that's intact over your all of your smoke detectors, because the source, americium-241, is an alpha emitter, and then most radiation, it's kind of not isolated to one particular source. So if you have alpha radiation or beta radiation, it's always accompanied by the release of energy, which is in the form of the gamma radiation. All right. So americium-241 is an alpha emitter, but it's a gamma radiation. It emits gamma radiation as well. So the plastic cover is really important to reduce the radiation to almost zero, and therefore you won't expose yourself to the harmful effect of radiation if your smoke detector has an intact cover. So what are some of the medical applications of radioisotopes, especially in nuclear medicine? So this nuclear medicine began about 50 years ago. It has become an everyday thing in most hospitals, all right? They are used all the time, whether to make a diagnosis or to treat and prevent disease, okay? So 1/3 of every procedure in modern hospitals involves radiation or radioactivity. And so these have become now life-saving tools. A patient cannot go into a hospital for some kind of treatment that doesn't involve some type of diagnostic tool in the form of a scan, etc. All right, these are safe and painless. They don't require anesthesia. They don't require exploratory surgeries to detect something. So there are things that can be diagnostic tools that you can use that are very safe and pinpointed to diagnose that particular ailment or disease, and they're used in all the different types of medicine, whether it's in pediatrics or cardiology, etc. Radiation oncology, the OCN certification for nurses, is one of the newest growing field. So in nuclear medicine, radioisotopes are either injected internally or it is done externally in the form of x-rays, etc. All right, and they always caution you to not take too many x-rays in a year, just to reduce your exposure to radiation. So both radiology and nuclear medicine can treat illness or diagnose it, and again, these techniques are safe, and the earlier they're done, the quicker would be the method to resolve those medical issues. X-rays, MRI scanners, CAT scans, and ultrasounds are using nuclear science and technology to diagnose different kinds of medical conditions. All right, all of these are non-invasive, so therefore that's great, because then the patient does not have to undergo any kind of surgery. The advanced nuclear medicine uses computers and detectors in addition to the radioisotopes. So what happens is, whether the radiation is internally given or externally in the form of an X-ray, you can image this. So you can do bone scanning, a PET scan, or the SPECT scan, cardiovascular imaging, to see whether there's any kind of infraction in terms of stoppage of blood flow, and any kind of diseases, tumors, osteoporosis. All of these things can be diagnosed, these various symptoms can be diagnosed. So they are useful because because of the radiation they emit. You can locate these isotopes, and therefore using the scans and imaging techniques, you can detect where the tumor is, or where there is the stoppage of blood flow, etc. All right, so radioactivity is administered. These radioisotopes are administered either by injection, or you take it orally, or you're inhaling it, and then the camera will capture the image of the emitted radiation. So then the computers will enhance the image, and then the doctors can detect where the tumors or the fractures are, or measure where there's an impediment to blood flow, or whether the thyroid is malfunctioning, lung, any kind of pulmonary lung impediments, and so on. Okay. And that's the end of this